if you see in a monolithic kind of applications, right? So where probably everything is tightly coupled, the code or your executable is one code, right? So you can just deploy it maybe in multiple instances. So the kind of vulnerability you will observe in a monolithic environment, right, for a monolithic application is limited, it's less. But here in microservices, is each service is independent, right? And we are deploying each service in a container basically, right? So you can see a lot of vulnerable points here, right? So attacker can attack any service because each service will talk to the other service over the network, right? This is the 4 C's concept basically, what we talk about in cloud native security world, right? First one is your code, your application code. Here it can be in the API, it is your API code basically, right? So the code you will deploy in a container. So this is the second C. But only containers are not enough, right? So we need to orchestrate all the containers. We need to control and manage the containers. That's where like cluster is coming into picture. So Kubernetes is cluster. Now to deploy that, right? So we need basically a cloud support, right? So that can be your data center. In under data center you might be having your virtual machines basically, right? So inside that you might be having your clusters, and then inside that containers, and inside that your code basically. So there is a cascading effect here, right? So there is a layers. So we will see one by one in each layer what is the security no need basically, right? How we can make our API secure here when you are deploying an API in a cloud environment. So first one is the code level, right? So the core, your API code basically, right? So there are two types of best practice we would say at design level we can consider. One is your static analysis and one is dynamic analysis. Static analysis is nothing but using code scanner. You should always scan your code for potential vulnerabilities, right? So you have to scan and see, generate the report and see if anything is not secure basically. There are tools, static code scanners are there, so that you can use based on the programming language or tech stack you are actually using. Another one is dynamic analysis, which is like you are actually creating attacks basically, like you are creating or mimicking malicious attacks, like SQL injection is one. So that kind of attacks you are creating using your test, and you are seeing if you are able to break your APIs or your code basically. That is in the design level or implementation level. So another one is like see in the microservices, right? So we'll be having dependencies basically, right? So a microservice, one microservice may depend on another microservice, which can be a third party API, right? So we should also scan for all the dependencies here. So it may not necessarily like all your third party APIs are secure. So you have to also run for scan for your dependencies. Basically like third party providers, right? So they do provide all this static analysis script basically, or your dynamic analysis script. They might be doing their own API security testing, right? So they generally provide those scripts. And if you're not getting so you should always ask for it when you collaborate with any third party, like if they have already have created any scanners, any or they have already any scanning this suit basically available, so we can get those things. Or if they are not providing it, at least we can ask for the reports, like your security scan reports, to make sure like our all our dependencies are secure. Another important point here is always we should go for HTTPS, right? So HTTP is not secure. So whenever we are developing our APIs, we should go for HTTPS as a transport. All this like user access or identity stuff we have discussed actually. So auth is one good way of authorizing your APIs. So all those we should consider when we write our code basically. Then suppose you are having client secret, right? So as you have come across examples where you have used client secret, then client tokens and all those things, right? So all those API secret and all those things should be protected. Now suppose you have written some code and which is just take that Spotify example, right? So to generate the token basically we need all the client secret. Now since you are actually using it as a end user, right? So it's fine, you are just learning purpose, you are using your own tokens and all. But think about an application, right? So which is actually using those tokens basically, right? So they also have to save those tokens or like secrets somewhere, right? In the code base basically, right? So because API, each time they will call the APIs, they have to use that secrets, right? So that is again a potential target of your hackers, right? So those are secrets basically. So we should always encrypt those secrets whenever you are putting those secrets in version controls, right? So nowadays people are using actually vault. So vault is again a secure, you can say, key value pair kind of stuff. Your service providers like cloud service providers like AWS or maybe GCP or Azure, they provide this kind of facilities. So always we should protect our secrets basically. Another important thing is here is like slow down the attackers. What does it mean, right? Suppose somebody wants to steal your credentials, right? So for a particular API. Now if you see auth kind of implementation, right? So we the first step is the basic authentication, right? Where we pass our username and password. Suppose hacker wants to steal it, so they have to try with different combinations of usernames and password, right? At least all the different combinations to hack basically, which can help them to crack it. So one way to reduce or slow down that process is rate limiting. If you remember, I was talking about rate limiting as a functionality, rate as a functionality of the API gateway, right? So we can actually limit the rate so that at least by the time it reached the limit, so it is gone for a day. Then again they have to try fresh, right? So it's just to slow down the process. You cannot stop it completely, but yeah, that helps sometimes. So these are the things which we need to consider as a code level basically when you developed your APIs, right? So at design level, all the scans, scanning third parties, always use HTTPS, right? And protect your secrets and all, protect your tokens, secret, and keep proper limits for the APIs. So these are few best practices generally they suggest to be implemented in the code level. So next, going to the second C, that is the container level. So container is, you can consider as a Docker here, right? So we have secured our code. Now we need to deploy our code in a container. So container level also, you need to make sure your container is safe, right? Now, like latest Docker implementation, they are providing signed images. For at least the paid one, they are providing signed images. So if you are implementing any application, we should always go ahead with this kind of images which we can actually trust, right? Then the Docker registry. Now you should always protect your registry, building an internal registry for your company or for your organization, for your product basically. So obviously if the registry is internal, you can very well protect it from your firewall and internal protection policies. So next thing is you should also scan the images basically, right? So container image is nothing but one place where you can see loopholes basically, right? So even see containers also, they will keep on releasing, right, versions. There might be bugs, right? There might be vulnerabilities. So you should secure no container versioning, as well as you should scan for the images basically. So the way we do a virus scan, right, for our maybe OS and all, so similar way container images also we should scan. And if you are maintaining any security practices and best practices, right, so it should be updated always, right? So because new patches will come, new viruses may come, right? So it has to be updated. If you are using antivirus like McAfee kind of stuff, right, so we do uh, update our policies, right? So they will send there are new things has been added, so new update will be there. They'll ask you to update your patches basically, whatever you are using versions, right? So similar way here also, our policies we should be keep on updating. Another one is like use rootless mode, right? So now even Docker, I think, support rootless mode, so root accesses will not be there. So we should always go ahead with rootless mode, so that it is secure. Because in root mode, right, so if you are comfortable using in Linux and all, so you can see we have root mode and all, where we can do a lot of things, right? Similarly, Windows, we have admin mode, right? So if we are providing root mode in the Docker container, that is more vulnerable again for the attacker's point of view. So yeah, always go ahead with rootless mode, so that it is more secure, signed image, and keep scanning your images, and time to time update the policies basically. So this way we can actually secure the container where we will be deploying our APIs. Okay. So next thing is the cluster, right? So we have secured our container, but that is also not enough, right? So because there will be a one layer above the container which will maintain the container, that is the cluster. So in this example, you can consider Kubernetes as a cluster, right? So again, no, here also multiple security mechanism you have to see and take care. First one is TLS. It's same like HTTPS, so you have to secure your transport. Then enable role-based access control. See, if you have clusters, and you might have multiple users, right? So we'll be using those clusters. So you have to make sure only the users which have permissions, you are adding access to those. Then auditing basically, so clusters, you will see logs, so you can always enable auditing of logs, so that if any thing like suppose you are seeing some IPs which are external to your organization in the audit logs basically, so you can block those based on that. Then you can also enable third-party authentication, like for example Google, Okta and all, so those can actually help you to provide better security. You can enable that. Then you should also rotate your encryption keys basically to mitigate the vulnerabilities. You should not always use the same keys. How you will rotate again depend on your policies basically, so that you should use. Another one is networking policy to limit the traffic between the pods basically. So that also you can consider. Okay, so this is basically to make sure your cluster is safe, right? We have secured the application, we have secured the containers, then we should also secure the cluster basically. So cluster is from where we will control everything. Okay, so these are some of the best practices generally they suggest, like we should do from the cluster level. So if all these things are done, right, so last is our cloud, right? So yeah, you have a container, but where you will be keeping the container, obviously you need some VM, right? So some infrastructure should be placed. Either can be a dedicated machine or it can be a cloud. Mostly, microservices, those are deployed in cloud. So we use VMs, right? So AWS EC3. So all these VMs should be secure basically, right? So cloud, yeah, they provide their own security mechanism, security policies, and you need to make sure all those things are in place basically, right? So infrastructure level, like data center level security, obviously they will provide. And next is the OS level security, like VM, your EC2 instance should be secure. Next is like account or user level security, whoever is using those instances, right? So maybe your developers, your testers, or any other person in your company who needs that access, right? So you should secure that. Then your data security, right? So you may need to keep some data in somewhere, like for example S3 bucket, right? So you need to keep some data. So how you'll secure it, right? So you may only give permission to the needed parties, right? Or maybe if it is code level, you should handle in the code level, right? If some confidential information should be masked before writing into those data containers basically. Then yeah, so these cloud providers generally, they publish their security policies and they adhere to the security policies. And basically if we are a consumer of those services, we should know even those security policies, like what kind of policies they are actually providing, and we should see if something is missing, or if you have any extra security requirements. Suppose, yeah, you are building a very financial application, right? So banking application, so what kind of security policies you may need to have. So you can always collaborate with the cloud providers. Another thing is, like, again, security auditing, monitoring and alerting. You have seen, like, this is important from the cluster point of view. It is also important from the cloud point of view. So they generally, AWS and all, they generally provide this kind of logs and audit logs and all. Then you can you know add your monitors, and you can alert, right, based on some, maybe if you're seeing some suspicious activities based on the logs, you can always alert the users. So those kind of things generally, this is very general, like all the cloud providers they provide. And we will be always using it. But yeah, this is like a 4 C's we call. No, you should protect the entire application in layers basically, like your code, then your containers, then your clusters, and finally the cloud, like one complete block. Clusters and containers level, your DevOps generally maintain it, most of the companies, because they are only who will be actually managing the entire step, like creation and then management, giving the permissions and all. Okay,
Okay.
so mostly DevOps guys, at least I have seen, if DevOps is there, development or testing team will not do that, like managing of your clusters. Okay. Yeah. So yeah, this is actually a top 10 API vulnerability list basically. So you can see these are the things, for they are actually giving the top 10 which we can target for our testing or for our development, like for example, broken object level authorization or user authentication, right? Ingestion, right? SQL ingestion, the rate limiting, whatever I was talking about, right? Functional level authorization, logging and monitorings, right? Some of the guidelines are actually provided. You can find it here. Mainly all the security engineers and security testers, they follow this. Okay. So they have actually top 10 for web applications separately, and now they are giving specifically for APIs. This is for only for API security. Okay, so if you go to their no this thing, they have regular top 10 for web, like that. So those are the vulnerability list they are providing. So this is specifically for the APIs which we can consider while writing our API test. For example, first one, right? Broken object level authorization, right? So what does it mean? Or broken user authentication, right? So user authentication is nothing but we have seen, right? So all our APIs, no, we have seen how auth2 can be used for user authentication, right? So those kind of things we can consider while writing our test, like rate limiting. For example, you want to test the rate limiting for a particular API, so you need to know what is the rate for a particular user, basically, right? So, and again, user will be having role. Maybe the rate limit for admin user will be more than the normal user. So based on those requirements, we can add our test, security test, basically. So for doing security test, there are multiple tools. One is there like Barb Suite. You can use Barb Suite for that, and then even it is possible to integrate Barb Suite with Postman. Okay, you can I'll provide you the links which you can explore, like how you can actually use Barb Suite, no, creating your security test. Then another thing is Postman is providing actually a security test generator here. Okay, so this is a GitHub. Again, they have given an environment as well as a collection which will be having all the details, like how you can actually do a security testing using Postman itself. Yeah, you need Postman APIs, Postman credentials, basically keys and all for that. But the process, how we can use it, how it works, basically, so they have explained in this GitHub repository. I have actually imported that security generator. So it has some APIs here, and it has added some test also. Okay, I have not executed it. You can probably explore. This is already available, right? So what you need to do, basically go to this GitHub page, and you can download this too, like environment as well as the collection. Then import it, and then you can try to analyze what kind of test actually they have added here. So API validation, components, then security test, right? So all those things they have added here. You can explore this basically for security testing. Suppose you want to do something using Postman only, right? So you can use this security test generator, or else it is also possible to connect Postman with Burp Suite. So there are videos. I will share you the details. You can try it out. Uh, Based on this vulnerability list, right? So if you see here, so they will create security checks basically based on that. So they'll try to inject something, for example, SQL injection, right? So how it works, and they'll try to inject something in the parameters and all. So and see if they are able to crack the password. So those kind of checks generally we do perform.